It was on D.
I know, it's not like that. Alright, guys, I'm gonna start.
Like Julia's
Sounds
voice.
good. Oh, Juliet, somebody, I need to copy your notes on history so I can study it tomorrow.
We have a quiz tomorrow?
Yeah.
This is my locker. No, wait, it's here. Right here. You have a quiz tomorrow.
Okay, absolute value. Okay. First of all, who knows what absolute value means? Use your own words, not what's in my notes that you may have already printed. Use your own words.
Isn't it like when you take the value of what you get and then it becomes like negative? You take the value of what you get and then you turn it like negative from whatever it is, positive or negative.
You're on the right track. Help her out a little bit. Very good. Okay. If you think about absolute value, it's just the distance from 0 on the number line. Again, the distance from 0. So let's quickly look. If I want the absolute value of -4, you probably all know what it is. What is it?
4.
Just 4, because you've been told just make it positive, right?
Yeah.
Okay. Why are you making it positive? Let's discuss.
We already said it.
So here, the distance from -4 to 0 is 4 units. Distance is always, always, always positive. Okay, distance will always be positive. Displacement is a whole other case. Okay, but we're looking at distance today. So the distance here is 4 units. Okay, so we are looking at the actual distance from 0. Therefore, our answer for absolute value turns out to be positive. Okay, because we're looking for the distance, which is positive. Now, if I have a positive number in the inside, it's the same thing. If you have +4, what's the distance over here? It's still 4 units. Again, the absolute value of +4 is still +4. Because from 0 to 4, it's also 4 units. Okay? We good? So, let's make a quick statement. The number inside the absolute value bar can be positive or negative. Agreed?
Yeah.
But the answer is always what?
Positive.
Again, good. The number inside the absolute value bars, those bars on the side, can be negative or positive. But the answer will always be positive. We're going to use that when we solve the equations in a minute.
But isn't it when there's a negative on the outside, that's when it becomes a negative, right?
On the outside, sure, absolutely, Juliet. If you had a negative out here, it's like saying take the negative of this. Well, that would be -4, yes. Very good.
What does the negative mean?
If you had, good question, if you had negative absolute value -5, it's just negative of 5. Again, this is +5 really. What's the opposite of +5? -5. Again, this value right here is really +5. And this is saying do the opposite of +5, which is -5. So the negative doesn't cancel here. Again, the negative doesn't cancel. A little thing for you to know, you cannot, okay, whenever you have an absolute value, you cannot multiply into the absolute value. Okay, so if you had and you were trying to figure that value out, you cannot distribute the two. Okay? You cannot distribute the two, and you'll see why. There are certain times where it will work, and there are certain times where it will not work. And when we're doing equations today, you're going to see that. What's up?
No.
Why are you looking at me?
I wasn't looking at you.
So what's the absolute value of this, guys? 1 times 2 is 2. In this case, if we distributed here, we'd get 6 minus 8. This would be one of the scenarios where it would work. Okay? Now, if we have equations, though, when we're looking at equations a little bit later, we'll see that we need to break up our equations before we can do any of that. Okay? We're going to look at equations today, not just expressions here. Okay.
Did you say this concept 19? Is this concept 19?
Let's start with an example here. Now, we said a minute ago, the number inside of that absolute value could be a positive value or it could be a negative value. Again, the number inside of this absolute value could be positive or negative. But this value over here must be positive. Again, a minute ago we made the statement. Underneath the, or inside the absolute value bars, it could be plus or minus. But here it must be positive, because we're taking the absolute value. So, based on the fact that the inside could be positive or it could be negative, I want to write two equations. Can somebody come up with the two equations for this? Brandon. Not the answer. I want equations. You're trying to give me the number here, and that's fine. We're going to get to a solution in a minute. Okay, but before that, hey, Brandon already got one of the answers, but hold on for a second. I want to see what the two equations are. Again, the inside of the absolute value could be positive or it could be negative. How do I write that with two different equations here? Trayvon? Plus or minus what? You're on the right track. Not necessarily exactly right, but you're on the right track with the plus or minus. I want two equations here, guys. Two separate equations. What could they look like? Not square. There's no square root, John. Daniel? Very good. Absolutely right. So, it's going to be either positive x minus 1 or negative quantity x minus 1. Again, the inside could be positive, which is what it is, or it could be the opposite of that value. And both of these still equal 4. Okay, both of those still equal 4. Again, the inside of the absolute value could be positive or it could be negative. How do we represent a positive or a negative? We make one of them positive and we put the negative sign around the whole thing, the other one. Well, there's a little bit of an easier way to do this if we then look at this. How do I get rid of this negative that's on the outside? Okay, I could distribute it to each, but if I don't want it over here, how do I get rid of it?
If it's negative on the outside and it's
No. Yes, we can, but I want to get rid of it. I don't want it on this side, Juliet. Very good. Who said it? Vanessa. Divide by negative 1 in this equation. Divide by negative 1 on both sides in that equation. What are you going to get on the left side? On the left side, you will get x minus 1. What are we going to get on the right side? Negative 4. So, if you want to ever split up an absolute value, just do this. Keep the inside the same and make the other side plus or minus. Again, keep x minus 1 the same. X minus 1 is here. X minus 1 is over here. Take the number that's on the outside, this 4 here, make one of them positive and make one of them negative. Okay, whenever you take an absolute value, that's the easiest way to solve the equation. Because of what we had in the beginning. Because of this part right here, we can say this part right here. Question?
What happened?
Miguel, Derek, you guys have a question?
What happened?
No? Okay. Now, in this case, we have two equations, so how many answers do we have? Two separate answers. When we get two answers, we have to check both of them to see if they both work. And you'll be able to pick up on a pattern soon, or you'll know when they won't work. For now, we're going to check them both. So in this case, let's continue down. We've got x minus 1 equals 4, and the other equation was x minus 1 equals negative 4. Solve them separately, please. Solve them separately for each value of x. Here, what do you get? And here? Brandon, what was the answer you picked in the beginning? Negative 3. Well, there it is. Okay. Where does it come from, these equations? What's the other answer? 5. Let's go back and check. Our original equation said the following. There's our original equation at the bottom. Take the 5, take the negative 3. Try them both. Do they both work? They do both work here. 5 minus 1 is 4. Absolute value of 4 is 4. Negative 3 minus 1 is negative 4. But the absolute value of negative 4 is still 4. So if you check both of these, they both work. Okay? They both work in this case. Now, in a minute you'll be able to see when they don't work, and we can make a sort of a conclusion about when it won't work. Okay, about when it will not work. Let's try the next one. This one's not in your notes if you're following your notes. What about this one here? Can somebody solve this for me?
Isn't it X4? Possibly.
Can X be 4? Plug in a 4. 4, check.
It's not going to work.
Why isn't it going to work, guys? The absolute value of whatever this is will be what? And what does that say? So this equation cannot be solved. Again, try any number for x and take the absolute value. You will always get a positive number, right? Check any answer you want to try. Try 7, try 12, try 4, try negative 4, try 5. Whenever you take the absolute value, whatever you check, it's positive. But that says negative, so there's no answer here. Okay? So we could say no solution. Okay? Another way of writing no solution is putting 0, empty set, diagonal, right? Like that one? Other way.
No, it's,
I think it was right.
no, I think it's straight down.
More of an angle?
Down, yeah.
45-degree angle, thank you.
Just draw a whole bunch of lines to it.
It does matter. Thank you, you're right. Good.
Other way.
If you drew the line the way I did the first time, remember theta from last year in geometry? Theta was the circle with the line through it. That's what it would look like. This means empty set, or no solution. Okay, another way of writing it is like this. Okay, that means the set of answers has no solution in it. It's a squiggly line with nothing inside of it. The squiggly line represents... Relax. The squiggly line represents the solution set. There is nothing in the solution set, therefore no solution. Again, there's nothing in here, thus no solution. Okay, let's try another one. Again. How about this one?
No.
She just said no.
Daniel, give me a starting point.
Gummy bears.
Somebody do not try to figure out the answer right away. Just go through the process first. Once you do it enough, maybe you can figure out the answer on your own.
I said, what time is it?
I need a starting point, guys. Come on, somebody raise their hand. Tell them what to do to start. Luis. Thank you, Luis. Girls, you need to separate. Move over this way. No, yeah, that's not helpful. Luis already said, get rid of the 4. Get rid of the 4. Because the 4 is not inside the absolute value. So subtract the 4 from both sides. What you're going to see next is that you get the absolute value by itself. Just like radicals, you have to get the absolute value by itself. Then you can do the plus or minus. Again, just like the radicals, get the absolute value by itself, then we can look at the plus or minus. Okay, so at this point, it's now the same as the last problem. There's no difference at all. Make your t-chart or your split column. You got 2y plus 3 equals 1, and 2y plus 3 equals negative 1. Look back at your last example. Again, we get rid of the 4. We have a 1 on the right side. We know absolute value. It could be a positive or it could be a negative. Just like last case, we had the negative 4 or the positive 4. So in this case now, we have a positive 1 or the inside of this. So this is saying, in words, the inside of the absolute value could be positive 1. It's also saying the inside of the absolute value could be negative 1. And that's true. The inside could be positive 1 or negative 1 to give me a 1 as an answer. Okay? Solve them both. Tell me what you get for these two. There? I can't hear you. What did you get for your answer, Daniel? I got -1 for one of them, sure. Which one comes out to be -1 here?
First one.
What about the other one over here?
-2.
Now, what do I have to do with this, guys?
You have to check.
Where?
Why? Plug it into the original.
In the original. Again, always, always, always into the original equation. The original equation. So, go back up to the top right here. Try it out. Again, you don't have to show this by hand always. Look, -1 times 2. -2 plus 3 is -1. Absolute value of -1 is 1. 1 plus 4 is 5. This one checks out. Next, -2 times 2 is -4. -4 plus 3 is -1. Sorry, that was positive number 4. -4 plus 3 is -1. Absolute value is 1. 1 plus 4 is also 5. They both work in this case. Now, we'll go through an example next where we can see why the other one will not work.
Don't you have to look the
It's just sitting on the side.
Rick said take care of it. That's a lot of.
How about you? Okay.
Too late.
Next one.
Why they ask not a lot of.
I've been listening to Bullseye Park. It's already been.
Absolute value of a minus 3 equals 2a. We need to figure out a, absolutely. What do I do for this one?
Ow, cavity. You have a cavity?
Okay, somebody's saying divide by a. Can I put anything inside of here right now? I can't do anything inside of here. I can't move anything in.
You divide by it.
Divide by 2.
Okay, if I divide both sides by 2, I'm just going to have this divided by 2. That's not going to really do much. That'll give me a over here, but the a's in the answer. You can't have a and a in both. Okay, we're going to do that. But what have we been doing the whole time, guys, when we have absolute value? How many equations do we make?
2.
So just start by making 2 equations. Okay? Now solve for a in both cases.
There's no.
Figure it out. Get your answers and check. Get both your answers and check both answers, please.
Awesome. That's how everybody else is.
Check your answers. You're just solving for a, guys. It's a normal equation. It should not be difficult. So we have 2 answers now, don't we? We got -3 here. Subtract a from both sides. You're left with -3. 2a minus a is 1a. Subtract a from both sides. -2a minus a is -3a. Divide by -3 on both sides, you get 1. Again, these are one variable, one equation. Algebra 1, if not before that. Now, at this point in time, look at your 2 answers. Look at your 2 answers and check them both. Vanessa.
The one on the left is not going to work. The one on the right is.
Why?
Because
She's right. Listen to her.
because when you plug it in, that would be the first one.
Cool.
When you plug in the first one, the answer would be 6.
And what's on the right side, though?
Oh, negative.
Okay, here's what you need to look at, guys. This side of the equation must be positive, right?
Right.
If you plug in a negative number over here, what does this side of the equation become?
Negative.
So this answer is automatically not right. Again, if any of your answers, when checked, yield a negative number on this side, it is not possible. Try plug this -3 in up here. You'll get -6 absolute value equals -6. Well, that tells me that 6 equals -6, which is not true. If your answer makes the right side of the equation, if your answer makes the side of the equation without the absolute value negative, it is not possible. Again, this answer right here made this side of the equation negative. Well, we just said a minute ago that the other side of the equation from the absolute value must be positive. So by just looking at that right away, you can see it doesn't work. And then we can check the other one. Put it away, John. Then we can check the other one. If we have the 1 here, 1 minus 3 here, -2. What's the absolute value of -2 though?
2.
And then if you plug in a 1 up here, you're going to still end up with 2. Okay, because it's 2 times 1. So the other one on the right does work. Again, check this number on your own, it will work. Check this one, it will not work. Okay, it will not work. All right. Now, for homework, we're going to do more word problems, but when you get your homework later, you're going to see that there's going to be a few of those to try. Some will work, some will not work. Make sure you check all of your answers. Always start by getting the absolute value by itself, like we did in this example. Where is it? Right here, we got the absolute value by itself, and then make your 2 equations. If you had a number like let's say you had a number like 3 out here. How do I get rid of the 3 now? Divide. Again, please don't multiply the 3 in. Just divide by 3, divide by 3. You'll get 2y plus 3 equals 1/3. Okay, and then you make your 2 equations for it. So if you have a number in the front, make sure you divide. All right, let's go into a word problem. Here's the first word problem. A machine fills oatmeal containers with 32 ounces of oatmeal. Doesn't work, John. Doesn't work. A machine fills oatmeal containers. You guys know that. You've tried that many times. That one works.
I don't know.
A machine fills oatmeal containers with 32 ounces of oatmeal. After the containers are filled, another machine weighs them. So we have a machine that puts 32 ounces of oatmeal in a container. Then another machine weighs them. Now, if the container's weight is off by more than 0.5 ounces, if the container's weight is off by more than 0.5 ounces, the container is sent back to the assembly line to get refilled. Again, so if the weight is off by more than 0.5 ounces, the container, we're going to say, is rejected, which means it's sent back to the assembly line to get fixed. Okay, the container is rejected. What we want to do right now, and this is going to be part of your homework and your assessments, is using absolute value, write an equation that represents what's going on here. Write an equation that represents what is going on here. And this is not an easy process at first. The more you practice it, the easier this becomes. Again, the weight of the container when the machine fills it is supposed to be 32 ounces. Another machine weighs that. If it's off by more than 0.5 ounces, it rejects it and sends it back and has to get fixed. How can we represent this using absolute values? How can we represent this scenario using absolute values? Any ideas? Trayvon? Plus what was it?
0.5 plus C.
For the container? Very, very close. 0.5 plus C equals 3. You're close. You got something switched up in the equation.
Is it C minus 4?
Yeah, it would be 0.5.
What are we looking at? Let's say, let me do a scenario, make it easier for you to think about. I weigh the container. It weighs 33 ounces. What's the difference from what it should be?
1.
1 ounce, right? Again, it should be 32 ounces. I put it on a scale after it gets filled, and it weighs 33 ounces. So that exceeds the limit, right? How did I get to 1 ounce? What did I do? Subtract it, right? I took the container's weight that I measured, and I subtracted it. So, if we call the container's weight C, like Trayvon just said, we're taking the weight of the container, and we're subtracting 32 from it to see what's missing. So, for example, if the container were 33 ounces, you have 1 ounce over. If the container were 30 ounces, you're 2 ounces under. Okay? Now, what else can I do here?
That shouldn't be absolute value too much.
Why?
Because if it's like under
Or?
or over.
Very good. Again, the container could be underfilled or it could be overfilled. So the differential between what you want can be like +1 or 1 over. Or the differential could be -1 or 1 under. So this value could be positive or negative. Well, that means absolute value. Now, what are the restrictions based on what the question said? What is the maximum it can be off by? 0.5. Okay? So, again, the difference between the actual weight and the desired weight of 32 is right here. It can be over or under, thus absolute value comes about. Now, that equals 0.5. Let's solve this equation. Separate it. Okay, again, separate it as always. Move the 32 over. What do we get here when I move it over? This one is easy. 32 plus 0.5 is 32.5.
Isn't it 31.5?
31.5. Very good. So, take a look at these numbers. That makes total sense because, again, the goal was to get it to be 32 ounces. And what we're saying is the limitations are the following. This is the maximum capacity. And what is this one called? The minimum. The minimum capacity. Okay, again, we have the maximum allowable capacity and the minimum allowable. Now, without absolute value, think about this scenario. Doesn't that make sense to you? If it says it can only be off by 0.5, well, 0.5 over is 32.5. 0.5 under is 31.5. Again, our target is 32. That's our target. We can be under 31.5. We can be over 32.5. And those are the numbers that we came up with. But absolute value comes into play when they look at this stuff. If you go on to study anything with engineering or management or assembly line or even stuff in business, you're going to see that you have allowable deviations. These are called tolerance levels. For example, a box of cereal every time has these tolerance levels. So you know in the box of cereal it says like 24 ounces, that's how much cereal is in it. I guarantee you it's not 24 ounces. It's probably 23.9 or 23.7 or 24.2. They give you an allowable tolerance on each side. Just like if you think about it, remember if you guys look at something, hold on, yeah.
Isn't that like when they sell the back of chips, it's mostly air, but there's like barely any chips in there?
Yes, there's mostly air. Then that's true also, but the idea is that if you miss by a little bit, it's okay in the idea of tolerance. So for example, if you bought a football, is every football made perfectly?
No.
There's always going to be some sort of deviation, right? So what do they do at the end? Here's my guess, and I don't know the exact thing, but my guess is the following. When they come up with a football at the end, they measure the length of the football, they measure the diameter, if you look at it as a circle in the middle. They probably also measure the pressure of how much is in the football, because if there's too much pressure and it gets hot out in the summer, that football could explode. Okay, like we talked about with the tires. So in this case, remember the tires the other day?
Okay.
So you always have a tolerance level. In some scenarios, you might have 3 tolerance levels.
You got the white checks on the face.
If your tolerance level is not met, that assembly line product gets sent back to the assembly and has to get refixed. Okay? Derek, you have a question? Okay. Let's do one more before the bell rings. And this one's a good one because there's several things. So draw a table. So what I want you to write is the item and deviation. Okay, the item and the deviation. So here's the question. The amount of items sold per week are listed in the table below. This is going to be at a certain market. It will be fruit. What is the total minimum and maximum amounts of items sold per week? So every week, So we have item, deviation, and amount sold. Apples. There are 200 apples sold every week on average, plus or minus 8 apples. So there could be 192 apples sold one week, there could be 208 apples sold another week, any range in between there. For oranges, you have plus or minus 10 with 250 sold. For bananas, you have plus or minus 16 bananas with a total of 540 every week. We'll have pears, we'll have mangoes, and we'll have pineapples.
You have broccoli?
No. That is not.
Who cares? I want broccoli.
I love broccoli.
You
Oh, I
can-
love plastic.
Guys, it's a fruit market for now, okay? Relax.
Oh, okay. Hey.
So, looking at the table, we have 200 apples are sold every week, plus or minus 8. 250 oranges are sold, or 10 less, or 10 more. 540 bananas are sold, or maybe 16 more, or 16 less. So I'm giving you the tolerance level every week. So this guy knows how many to estimate he's going to sell. So every week, on average, the amounts are listed, but they can deviate from the norm. So you can sell maybe 5 more apples, or you could sell 6 more apples, or 7 or 8. But you can't sell any more than 8 more or 9 more apples in this. So 209 apples cannot be sold in this case. Try on your own, figure out the total amount of fruit that can be sold, maximum each week and a minimum each week. Again, every week, find the maximum number of fruit sold and the minimum number of fruit sold. Your homework worksheet is right here. Okay, I'm going to place it right here next to the pencil sharpener. Please take one on the way out. There will be extras. Take one on the way out.